Okay, in the last video we looked at monatomic ions. So if I had something with single elements, how do I combine those together? What if we have something that has multiple atoms in the anion, or cation for that matter? So this is something that's pretty common. You have a whole formula, and this would be something called a nitrate group. The whole group here has a charge. In this case, it has a 1- charge, or just a negative charge. Okay, so if I have Na, and we learned in the previous video, if I have Na, it loses 1 electron, so it becomes 1+. NO3 is 1-, and I combine these together. The thing that people get mixed up with the most is this 3 here sometimes throws people off. Don't get thrown off by that. The whole thing has a negative charge. And so when you combine them together, not to worry about this, I'm just gonna write Na, 1+, NO3, 1-. I only need one of them, one of each. So in this case, my formula is just Na, NO3, because they balance out. And this is sodium nitrate. What if I take calcium with nitrate? So calcium is in the second column. It's got 2 valence electrons. So it's got 2 valence electrons. It's going to lose those 2 and become Ca2 positive. NO3 stays with 1 negative. The whole thing, remember, is negative. And so how do I write this out? Well, if I have Ca2 plus, NO3, 1-, and I look at the charges, well, this has got 2 positive charges, this is 1 negative charge. I need more negative charges. Think of this whole thing as a group. All I just gotta do is add another group. I don't even have to write it in there if I don't want to. Okay, and so there's 2 of them now. 2 pluses, 2 minuses. That means I have Ca, imaginary 1 there. NO3, there's 2 of them. When you have 2 of a group, you have to put it in parentheses like this, and then you put the 2 on the outside. And that tells me that I have 2 of whatever is inside here. So this is calcium nitrate. Well, what if I have something like OH? So this is called hydroxide. It also has a 1- charge. Magnesium, my periodic table says I have 2 valence electrons. Let's set it up again. 2 valence electrons. It loses those 2. So it becomes Mg, 2 positive. I have to do these. So Mg, 2+, OH, 1-. Do my either crisscross method or my balancing method, and I see that I need more OHs. Even though this has no numbers here, if I write Mg, there's 1 here, and OH, and the 2, I cannot just put the 2 out here like this, because the 2 needs to go for the whole thing and not just the H. So you still have to put parentheses around the OH, and that tells me that the 2 goes for both things and not just the H. And this is called magnesium hydroxide. Okay, how about this one here? So this is Na. We know that Na is 1+. PO4 is called the phosphate group. It has a 3- charge. So when I put these together, I have Na, 1+, PO4, 3-, and I have too many negative charges, so I need more NAs, a couple more NAs. Okay, so that works out. And what do I do now? Well, I need Na. There's 3 of them. So by 3 here. PO4. Just 1 of them. So you don't need to put a parentheses around this because it's only 1 of them. And you don't put a parentheses around the Na because it's just 1 element. You can put a 3 out the outside. Or if you did the crisscross method, you can see the 1 would go here, the 3 would go here, and that's where the 3 comes from. So this is sodium phosphate. And the last one, this is called the ammonium group. Ammonium is NH4, NH4, 1 positive. SO4 is the sulfate group. It's 2 minus. So when you combine these together, if I want to crisscross this, you can see how that works out. That would be NH4, and there's 2 of them, but because this is a whole group, I'm going to put this in parentheses. And then it's SO4, and nothing on the outside because there's no number, it's only 1 of them, and this is ammonium sulfate, like that. Okay, so that's how you write out formulas like this and figure out. The best way to figure out charges is, frankly, memorize them. It's probably the easiest way if you just know there's a lot of things that are used over and over again. If you want to go backwards, we can take those apart and figure that out. For instance, if I were to have, let's say I had something like copper, Cu, and I had NO3, 2. And copper is one of those elements that's in the middle of the periodic table. It's a transition element, so it can have a variety of charges. And I wanted to figure out what the copper charge was. Well, if you know that nitrate is always -1, 1 minus, then copper, in this case, because there's 2 of the NO3s, and copper has to balance that out, then you know copper is going to be a 2+ charge in this case. NO3 is always 1 minus, and that's how that balances out. Okay, so